Good morning, students. I welcome you all to today's physics class. I'm going to be your teacher for today. Akinrawa Akimbowale is my name. So let's get started with what we have today. The topic before us is Introduction to Sound Waves. Now I would like you to pick your notes and write out the lesson objectives. These are the objectives for today. Explain the propagation of sound waves. You should be able to differentiate between music and noise. Then you should be able to list and explain the characteristics of a musical note. As your starter activity, I would like you to mention 3 characteristics of waves. You've been taught waves, I know, so I want you to mention 3 characteristics of waves. Let's go to the lesson proper. Sound is a form of energy that can be transferred from one place to another. It is produced through the vibration of objects. Sound produced by vibrating source is conveyed to the air in the form of waves. Sound can never be made except there is a vibrating source. Oh, how do you hear sound? When the sound enters into your ear has 3 compartments. The vibration will be sent to the eardrum. The eardrum vibrates at the same frequency as the incoming sound. So it sends the waves into the inner ear where it is being sent to the brain for proper interpretation. Talking about how sounds can travel, it can travel through solids, liquids and gases, but not through vacuum. Then, what is a vacuum? A vacuum is an empty space. How then do you know that sound cannot travel through vacuum? I know you've heard about rockets that have been launched into space. The space I'm talking about is a vacuum. You might have heard about explosions happening in space. But why is it that you don't hear the sound on Earth? It is because sound cannot travel through vacuum. Sound travels faster through solids. It is very, very fast when it's traveling through solids. Slower than that when it is traveling through liquid, and then slowest through gases. Why will sound travel fastest through solids? It is because the molecules of a solid are well packed together, so the vibration is quickly sent in successions, while that of liquid, loosely packed, is not as tightly packed as solid, and while that for gases, the molecules are free, they just bombard each other. So how do you know when sound travels through a solid? For instance, if you hit your table, you hear the sound. If you have been to the river or ocean before, you hear the sound of water waves or tides. Then, the most common method of transmission of sound is through air. Audible frequencies range. The human ear can easily detect frequencies between 20 Hz and 20 kHz, that is 20,000 Hz. What we are saying here is that there is a range of sound that the human ear can hear. Once it is below 20 Hz, it cannot be heard. And once it is above 20 kHz, it is too high for human ear detection. So sounds that are within this range, 20 Hz to 20,000 Hz, are known as audible sound. Now, when the frequency is too high, we call it ultrasound or ultrasonic sound. Ultrasound is sound waves with frequencies higher than the audible limit of human hearing, while if it is lower than the limit of human hearing, we call it infrasound. Now, what do we use ultrasound for? There is what we call ultrasound imaging or scanning, where an ultrasound scan uses high frequency to make an image of a person's internal body structure. Can you guess what that is? Have you ever heard about that before? Okay, if not, that is what is used to scan the womb of a pregnant woman. It can even be used to determine the sex of the unborn baby. Echolocation. What is echolocation? This is also another process used by animals such as bats and dolphins to send out ultrasound waves. When the sound wave hits a solid or an obstacle, it is reflected. Reflection means throwing back. It is reflected, and then the dolphin or the bat will use that to identify the location of the objects that they cannot see. Speed of sound. The speed of sound actually depends on the medium. Like I said earlier, in solid, it travels fastest, liquid and then gas is slowest. It also depends on the temperature. The higher the temperature, the higher the speed. What I mean is the speed increases with an increase in temperature. Noise and music. Yes, we divide sound waves into two. There is what we call musical sound and non-musical sound. Musical sound is simply called music, while non-musical sound is called noise. When sound waves originate from sets of regular frequency, fixed frequencies, we call it music. Music is a type of sound that is pleasing to the ear. But when it is coming from confused or mixed frequencies, it is called noise. This is not pleasant to the ear. Now we go to the characteristics of a musical note. Pitch. This is the position of a note on the musical scale, and it depends on the frequency. A little explanation on this. Now, pitch. If you really understand music, if you are on a particular key, that is talking about octave now. Okay, let me quickly run an octave for you. Do, re, mi, fa, sol, la, ti, do. You see that I started from do and I ended at do. The two are the same, do, but one is higher than the other. So the one that is higher than the other one, do, is of a low pitch. Do is of a higher pitch, meaning it has a high frequency. I believe with that you understand what pitch is. Loudness. Loudness is just the sensation of the sound in the ear of the observer. It has to do with the amplitude of the sound in the ear of the observer. So it depends on the amplitude and it depends on the observer. That is to say, I may listen to a certain type of music. If the volume is increased, it may not be too loud for me, but it may be too loud for you, depending on the ear of the observer. Another one that is closely related to loudness is the intensity, which is the energy transmitted per unit area. People confuse these two, but loudness is slightly different from intensity. Okay, let me cite an instance. Let's assume you increase the volume of your disc player to 20, for instance, and you put it outside. Well, of course, 20 may be loud, but because it is transmitted through air, the loudness, or let me say the intensity, will reduce. But now go to your room, a very small room, and use the same volume of 20. Now we don't talk about the loudness increasing because it is still the same loudness, 2020. But because the room is smaller than the previous one, the intensity will increase. That means the energy per unit area will increase. This depends on amplitude. Then another one is the quality or timbre. Quality or timbre. We all listen to music. Okay, let's assume you are playing the same type of music using a violin, using a piano, and using a saxophone. A very good listener will be able to differentiate between violin, saxophone, and piano. That quality of music, that's characteristic of a musical note that makes you differentiate between the sound played by different musical instruments within the same frequency and within the same loudness is called quality or timbre. If you are sleeping, if a violinist plays the violin and a pianist plays the piano, you'll be able to differentiate that this sound is coming from a violin, this sound is coming from a piano, even if they are played at the same loudness. So that is called quality. Now it depends on what we call harmonics and overtones. It depends on a frequency which is called fundamental frequency. For instance, the other time when I talked about do, re, mi, fa, sol, la, ti, do, I can go again from now. Do, re, mi, fa, sol, la, ti, do. All the do's are multiples of the first do. So that is what we call overtone. Okay, ladies and gentlemen, thank you so much for today. We have come to the end of today's lesson, and I believe you really enjoyed it. So stay tuned. Next time, we are going to continue this topic. Now I want you to turn over to the instructions given to you. Now read the notes. We also have the notes for this. Read the notes and then do the assignment. Make sure you turn in your assignment. God bless you.